What an amazing day. Are you ready to take off? Fasten your seat belts. We take off to space. So we will reimagine exploration with fleet space technologies. New ways of exploration. Does it really work on Earth? Is it economical? Can it be scaled up? Has it been proven? Found something where the find is correct? So Flavia is going to tell us all of it. So I want to invite Flavia, Tata Nardini, CEO and co-founder of Fleet Space. She is a space engineer, starting her career as a propulsion engineer at the European Space Agency. She was recently screened for astronaut training. If you're lucky, we may share some about it. Flavia?
Thank you, Doris. So there are no secrets. I'm not a geologist, I'm not a geophysicist, I'm a rocket scientist, so I'm probably in the wrong room, or maybe not, okay? So let's talk about it. Sorry. Okay, I've co-founded Fleet 10 years in August. I remember quite clearly because I was almost 9 months pregnant with my second daughter. And as you do when you're 9 months pregnant, you found a startup. It's been a hell of a journey, a beautiful journey, and I want to share 5 minutes with you about it, and then I invite my team to discuss a little bit. Corporate boring stuff. Fleet has just, we actually had the honor, I call it an honor for space technologies in mining, to raise our Series D this year with the team at OTPP in Canada. A big round for our technology in mining and exploration. We launch satellites. We have a constellation of satellites, of 10 satellites dedicated to exploration. So yes, I'm a rocket scientist, and one of my dreams was, and still is, to change and accelerate exploration by using AI in space. So we launched small satellites as big as probably this little table. We launched them in real space with SpaceX. We provide service to probably most of the tier 1 company out there on the 5 continents. So it's been a quite interesting journey. Let me tell you more about it. So this is the photo that inspired my journey. This guy is Buzz Aldrin. We are in 1969. I wasn't born. I was born in 1983. But if any of you was there, don't put your hands up, otherwise you'll give your age away. But Buzz Aldrin, when he went to the moon, he actually did a lot of experiments. The one that you got in front of you is a passive and an active seismic experiment to understand the subsurface of the moon. Was a passive. Not a lot of people know there was an active experiment as well, so they actually brought some grenades, and they wanted to understand the subsurface of the moon. There are 2 things that really fascinate me about this photo. The first one is, this is the first time that actually an experiment to understand the moon was deployed, and this experiment changed completely the oil and gas industry. So the complicated structure of the inside of the moon meant that the NASA engineers and scientists had to very complicated understand 3D seismic processing. And this journey really led to seismic to be the most used technique in oil and gas. Seismic, so the understanding of the waves under the earth, is 80% what they use in oil and gas, is what made oil and gas the industry that it is today, in good and bad. Now, the interesting thing is that this photo from space to tell a story about oil and gas, but tell also a story about AI. So 10 years ago, NASA took all the data that they saved in this experiment. The experiment lasted 28 days. That is the time of the moon day. In the moon night, it gets really cold, so you can't gather data. They gathered a lot of data. And in 1969, they tried to understand what was it. And they couldn't. They thought there was one moonquake. They really struggled. There's a lot of data. So as NASA always do, they put aside some technologies, and then they get data after many years, and they're running with other technologies. So 10 years ago, they ran these data sets with ML. So NASA scientists took an ML algorithm, ran this data, and realized there were thousands of moonquakes due by expansion and contraction of the moon and meteorite landing on the moon. Beautiful. I'm an entrepreneur, so what I really like about, I would say, technology advancement is like, why now? Like, mining it's actually complicated. Like, as I explained it to my daughters, and they're around 10 years old, it's easier to find a pocket of gas and oil between rocks than find a vein of gold in a rock. That's the reality. So ML really made the change for this industry. Now, a few years after, now we're talking about really a few years ago, NASA sent another experiment, the InSight mission, on Mars. And guess what this one was? A seismic. So there was another seismic experiment, and what you see here is the first time in humankind that experiments of the subsurface characterize an entire planet. So what you see there is the characterization of the entire planet of Mars with some geophones and some AI in another planet, okay? Not a lot of people know, but if you are in the middle of US, or you're standing in the middle of US, you can actually, with instrument, measure waves coming and crashing on the California coast, okay? Earth is a beautiful, beautiful place, very noisy, and subsurface is very interesting. So in my industry, this has been happening a long time ago, okay? We are exploring the subsurface of other planet with seismic in mining, okay? Seismic mining is not very well used. So a few years ago, we decided to introduce seismic technologies in mining using AI. One of my big, let's say, assumptions, and these things you know, okay? I'm a rocket scientist. I moved to Australia. I got to know the mining industry when I was there. Did I like it? No. Okay? I thought it was inefficient, environmental unfriendly, and the things that really, really was more interesting for me, it was the amount of data that was present everywhere but not used. That was quite interesting to me, okay? Because in my industry, despite the fact that Tesla might go down, my industry has been changed by a man that came from the software world. And SpaceX changed the way space has done forever. Like when I was launching my satellites 10 years ago, that would cost $5-6 million for each satellite. Now I spent $200K. Like my industry, so building rockets to go to space, has changed from an entrepreneur from another industry, okay? That he came to my industry and said, okay, there are some problems here, why don't we fix it? And when I came here, I always talk about naivety to come from another industry. I realized that we literally have to change the way we operate. You know, it takes 15 years to create a new mine, so exploration is low, cyclical, decisions are not made in real time. It's just a long journey, isn't it? The things that for me was more interesting, that 1 out of 200 drill holes found an interception or even. So these are the stats. So we are talking about 5 million drill holes in mining in the past 10 years, and 0.1% found anything. Now we are at the cusp of a growth for an industry that has to change the way they operate, right? Just in context, oil and gas is an industry that really, really operates with data, really operates with geology and geophysics working together, great software platform, we'll talk about it. And the success rate is 1 out of 2. Okay, they would never drill without having a full plan, and it's just a different industry. But that really told me that there is efficiency to be found. As an entrepreneur, I went for it. So what we decided is what I really wanted to do is work more on geophysics and connect every geophysical technique to space. So my vision and my theory, hopefully is working out, is that if you are able to move data in the cloud as fast as possible when you are exploring, you can actually use AI real time. Remote areas are really big, and it's very difficult to have real-time decisions when you are in the field. The field is tough. So we started creating probes that are connected to space. So we build our satellites, we build the probes, that really allowed from the ground to go up to the cloud and run AI. So we actually fully start company that built all these elements. And then we started saying, okay, so we started with seismic. We're a big fan of seismic. So we do passive and active seismic. But we started kind of integrating all the multiphysics and changing every single technique. So I love geophysics. It's a really good subject because it's literally the ability to listen to the subsurface of the planet. So there are a lot of techniques that are used, gravity, MT, active seismic. There are many, many, many. Most of them are quite old. Like the industry has been using sensors for 40, 50 years, and they are a little bit outdated. No one really put himself in a position to say, let's change it. What was important to us is scalability. So what we decided to do is get all these multiphysics properties and sensors, make them smaller with like MEMS or quantum sensors, connect them to space, and run AI, okay? But not AI large scale, AI to actually understand uncertainty in areas and get you closer and closer to success. Now, the things that we'll talk about today, that in this journey, we got exposed to so much data that we build a platform that integrates a lot of data sets in our tier one customers. So we're trying to integrate them to actually change this industry a little bit and making sure it goes well. Now, before I pass it to Doris, Fleet is launching next year our probes on the moon. So it is going to be the first Australian, it's actually the first probe coming back to the moon after Buzz Aldrin. And we are launching with a commercial spacecraft. And it's going to land in August 2026 to understand and study the dark side of the moon. So we're going back in circle. Voila.
There. Just as well introduced. Keenan Jennings is former VP of Mineral Exploration at BHP. With 35 years of experience, Keenan can share the challenges and opportunities for disruption in our industry. And Mick, I think he's Jack Muir, head of machine learning, uses geophysics to create decision-making tool sets for mineral exploration. A mathematical geophysicist with a PhD from the Caltech Seismolab, and Mary Skłodowska-Curie Fellow in Physics at the University of Oxford. Thank you. Hello. So, Flavia, would Fleet Space be the Google of exploration? If that was the case, how would you bring that vision to life?
I hope so. So I really want Fleet to help the entire industry. Like, this is my life work, and I'm very fascinated about exploration and critical minerals, and I want us to give the tools for the explorers to explore faster. We don't have a lot of time to find all this, depending on pricing. No pricing, the reality is that we really need to change the way we operate. Now, understanding the subsurface, I don't think there is anything more fascinating, like probably understanding the stars. Understanding the stars of the surface are two of the biggest problems of humankind. Being the Google of the subsurface, it's a big word, like, scanning the entire Earth is not something easy. Like, we don't use satellites to scan. We use satellites to move data, okay? Because to scan the subsurface, you really need to be close to the subsurface. What I really want to do is What I always say, and we'll talk about it, the biggest problem of big data sets is their quality. Like, bringing all data together means hard formats, a lot of cleaning. As I always say, it's like Tesla or other electric car are not really trained on Google Maps, right? They're trained on their own sensors, because if you really want to understand something at large scale, you need to have your acquisition system. And not a lot of people understand why a satellite system could change the way AI is done in geology or in geophysics. What I know that in the past 5 years, working with the biggest company in the world, they share with us all the data sets. So the amount of data, because we do like real-time surveys constantly, it's so big. Like, you know, we have done the first couple of years that we started 500 surveys plus, and the petabytes of data that we are collecting, it's enormous. So I think we are well on track to have a huge data set that it's exciting.
Talking about data sets, at PDAC, we started a session called Accelerating the Transformation. And we had BHP, Rio Tinto, and we all agree bravely to talk about all the issues. And that I think BHP said openly, most of our geoscientists, they're looking for the data. So we agreed, let's build an open data ecosystem. And then we started in that journey, and we found out two problems. One is everybody's collecting data differently, so it's not even shareable. Second, they won't share the data. So Keenan, so can you talk a little bit about it? So some have data fragmented, it's no use, they think no use for them, and others, they think they have to hold on to that because it's safe to do that. So can you unpack that?
Yeah, thanks, Doris. I think the first thing is thank you. This is my first time to Stanford, my first time to San Francisco. It's a pleasure to be here. I want to thank Jeff and Kurt as well for helping establish Mineral X. I think it's a fantastic forum. I probably have more questions than answers, so I put that out there right up front. The thing I would say about data is you need to have 4 things in place for data to be effective. And they all begin with you. And the first one is it needs to be useful. I have a piece of rock and it's got a gold value in it. It's a gold value I'm interested in. So it's useful to me. But is it usable, which is my second pillar? So the second usable. Do I have a coordinate from it? Do I know where it came from? Because if I didn't know where it came from, it's just a really nice piece of rock that I can put on my shelf. So I need to have integrity around where that's come from. The third U is it used? So is it useful? Is it usable? And is it used? Because if it's not used, it becomes irrelevant. In fact, if you can take any one of those 3 U's away and it becomes irrelevant. So when we have data hogs, data pigs, I call them. I'm a geologist, so I can talk freely about this. Geologists are data pigs. All we want is more data. The answer to the data is get more. So we never know where to stop. We will always be at the trough. Because of that, we stop ourselves using the data, and we collect it in all different manners. The 4th U I haven't mentioned yet, and that's uncertainty. And it's all the things that we've been talking about today around how do we make this data useful, usable, and used. We embrace uncertainty on that data. We spend 95%, there are far better experts in this room than I, around cleaning data, processing it, etc., getting it into a format that we can make it useful, usable, and used. But if we actually say, hey, let's put an uncertainty flag on this, then we're mapping uncertainty rather than mapping X marks the spot on Kurt's map. So I guess from my perspective, when we look at data and how people sort of try to think in a proprietary manner about that data, I would challenge them around, are you making that data useful, usable, and used? And even then, are we looking at a map that maps uncertainty, or are we looking at a map that we're saying X marks the spot? Because I can guarantee you X does not mark the spot.
Thank you. Talking about data, it requires collaboration. And Flavia, you talk about different level of collaboration. How do you see openly collaborate and still having a competitive advantage?
This, of course, is the $100 million question. So a couple of weeks ago, I spent an entire weekend that, Keenan makes fun of me because I should have a life, okay? But I guess what I've done. We always compare this moment on mining to oil and gas, right? So I'm there reading books and books and books and books and talking with ChatGPT and Google and all these beautiful intelligent machines online to try to understand how did oil and gas do that? How did the oil and gas got to a point that everyone was sharing data, that 4 months were perfect? Didn't happen overnight, okay? And the more I looked for it, I realized that 4 things happened, almost five, in the industry around the end of the 90s, at the beginning of 2000. They really flipped the switch in the oil and gas industry. One, okay? The government start working together. So they've got data sets, they start working together, they start, collaborations. UK starts collaborating with Australia starts collaborating with the US. They start sharing format, the way things are gathered. There's a lot of inter-government relationship that happen. 1. 2, Shell becomes a leader. And Shell start the OSDU, okay? That it was a platform for seismic data and many other data that actually set the standards for data, okay? So we have one of the big guys that pioneered. For information, BHP pioneered the OSDU a few years ago, but is not having a lot of success. Why? Okay? So we got now government working together. We got one big guy taking the initiative. But the other 2 things for me are even more interesting. So Equinor, that we all know at that point in time, I don't remember how it was called, exactly, Statoil. Statoil opened the data. So they woke up one day and they put all the data there. It's like Rio Tinto wakes up tomorrow and say, I'm opening up all my data. That it was offshore data. It was insane. It started something absolutely unbelievable, okay? And the 4th one, that I think that's very interesting for me, is Schlumberger created petrol, okay? So there is a company now at this point in time, they build a software called Petrol, like the API is starting to be the same, the format started to be the same, the government start collaborating, people are starting putting open source data, and a provider build a platform that everyone freaking love. And they all started using, so Petrol lead the charge, okay? So at this point in time, if you look at these 5 elements, we have barely none of them. Like BHP is trying to do something with the OSDU. There is no one opening data, like Kurt is screaming about it, and now you understand why, because it's one of the 5 elements for success for this industry. Like we don't have any Equinor sharing data, and we don't have Petrol yet. So what we're trying to do at Fleet is, there is a room for Schlumberger critical minerals. In exploration in critical minerals, there is not a provider that helps everyone end-to-end, and there is not a Petrol. So that's what we're trying to do. We are trying to build the Petrol of mining, and we need partners, and we need to stick together, because I want to find the Equinor of mining, I want to find the Shell of mining, I want to build the Petrol of mining, and this industry will change.
Will that be the iPhone of geoscience?
Anything will do. BlackBerry, I don't care. Better than this.
Jack, the success rate in exploration isn't really very good. So we talk about collaboration, data, but how Fleet Space will impact and improve in the success rate of exploration?
Thanks, Doris. Yeah, so we are trying to, I guess, change this data story as Flavia was discussing. So I think that's step number 1, is that we need to try to empower people to use data more effectively through a good platform. And a lot of that is going to be trying to encourage people to take up standards like they have in the oil and gas industry, or at least trying to catalogue things correctly. A lot of it is going to be trying to use active decision-making tools. So as Keenan was discussing, what we want to be able to do is try to understand what uncertainties are and try to map those out efficiently, trying to reduce search space as efficiently as possible. That's probably one of our big mantras internally, is that we're trying to do a search space reduction problem at the exploration stage, or trying to quantify things most cost effectively at a local stage, and that requires a lot of maybe more quantitative decision-making tools than we've used in the past. That's what MineralX has really pioneered in its collaborations with its various partners. What Fleet's trying to bring to the table is making tools that are really useful for that from a geophysical sense, like ambient noise tomography, like magnetotelluric methods, things that were challenging to deploy in the past and would have very long turnaround times, so they're not really suitable for use in an active decision-making framework. If you leave traditional ambient noise out in the field, before Fleet came around, the turnaround time would be 6 months or more before you got the data, and with us it's 48 hours. And once you get down to 48 hours, then you can start changing your drilling plans on the fly to best characterise things. It's a combination of that technological development of geophysical tooling or other sorts of tooling that gives you better insights, and then the ability to feed that into a quantitative decision-making framework and actually do that decision-making realistically. Because if you have to wait 6-7 months between decision points and your timelines are 10 plus years, we're not going to solve the mineral production problems that we are looking for today. So that's what we're trying to do.
Okay, just coming back to this iPhone of geoscience, how would that work from your point of view?
I think it's an analogy that can be unpacked in a lot of different ways. I think for Fleet, part of it is delivering like a delightful user experience is the key thing of the iPhone. So that's part of what I was talking about. We have these potentially really great techniques that illustrate a lot of information about the mineral system. So we have ambient noise tomography, we can sense mechanical properties deep into the earth and understand what is the source of mineralizing fluids, how is the alteration pattern expressing itself in the surface. You need to cross-reference that with other geophysical tools or other geochemical tools in the near surface. One thing we're investigating, for example, is magnetotelluric method for doing that, because that gives you the sort of depth penetration required to be able to correlate things correctly. These are all techniques that have existed in the past. Some of them for 50 years. For MT, ANT has been out in the academic sphere for 25 years as a pretty core technique used by academic groups to understand crustal scale stuff, but they've all been just like unusable in practice because they're like at scale, because they're too slow, and the deployment characteristics are too challenging. MT, for example, there's like the main provider has frequent failures of the SD cards, things like that. Requires skilled field crews to be able to deploy the instruments. They break all the time because they get caught on tree logs or whatever. So we've really excelled at is solving a lot of these problems and providing a user experience that our customers love using, letting them do experiments that they couldn't conceive of doing possibly, because it's now logistically possible for them to do so, and that means that they have more data in interesting locations and, as I said, can actively plan that. The other thing I would say is that we want to provide a platform, as Flavia was saying, for people to use, and that's the sort of underlying software part. Not the fun, nice user experience software of the iPhone, but like the underlying APIs are really important. So we need to really try, and this is obviously going to go beyond Fleet. This is something that everybody needs to have buy-in for, is to provide clearly defined APIs for how to operate between companies, so that we can integrate each other's data into products, and then allow us to actually work on things effectively.
Just to perhaps elaborate a little bit on the iPhone analogy, other smartphones are available, I guess I should say. But the iPhone is it was a phone when it was first launched, and then it became a camera, and then it became a high quality camera, and then it became a wallet, and then it became a social engagement platform, then it became our work platform, then it became whatever it became, right? And one of the things that really slows us down in the minerals exploration business for discovery is that we insist on doing everything in series. We do a piece of work, we step away, we think about it, we scratch our heads, we go back out there, we do another piece of work, come back, scratch our heads, it's the rainy season, so let's stay a little bit longer, etc. And it just takes us a very, very long time to achieve an outcome. When we start moving these processes into parallel, when we start becoming the iPhone of minerals exploration, where in a single logistic effort we can go out and gather passive seismics, active seismics, EM, perhaps some geochemistry, etc., we can accelerate our decision making, we can accelerate the mapping of our uncertainty to speeds that are unrecognizable to the industry today. So for me, when I think about the analogy of the iPhone to minerals exploration, I'm thinking of how we can integrate and get cooperative data sets in front of us much, much quicker than we do today, which is ponderously slow and is the major handbrake on our discovery track record.
And just following up again on that slightly, I guess one of the really key outcomes of what Jeff's group has been showing is that if you do treat the acquisition of data process as like a unified combination, like a sequential problem where you have multiple different options and you want to optimize that to give you the best possible outcome for your exploration process, that gives you, quantitatively different answers to the old style of doing things, and it will give you better answers. And what we need to be able to do is like develop processes that allow us to operate in that fashion, and that's what we're trying to do.
Excellent. Flavia, 5 years from now, how do you see fleet space has transformed exploration?
I really, really hope that room from Schlumberger in critical minerals will be filled by our shoes. I really hope that we can help every explorers end to end. I really hope that the decision maker trust AI, all of them. I really hope there are a lot of discoveries, and I'm not saying, a lot of people say it's like we need 300 more escondidas. Yes. I'm talking about many. I'm talking about completely changing the way we operate. For this to be true, there are a lot of things that needs to happen. Like for fleet to provide this, really a lot of things needs to happen. But I think these things are in motion. I think this industry is changing a lot. They were talking about speed, and it made me laugh because when we started providing services with the satellites, like 4 or 5 years ago, everyone was like, why would I have to, why do I need data real time? Like to create a 3D of the subsurface usually takes me 1 year. So I would ask, what's real time for you? And that would be 3 months. I'm like, I can do better than this, okay? So for me, real time was hours. And despite the fact that now my team is on board, you should have seen them 2-3 years ago when I was telling them, I know you laugh because you know exactly what I'm talking about. So I put them this challenge.
She wants 5 minutes, actually. That's the secret number. But
yeah, my secret number is 5 minutes, But I started with 48 hours because 48 hours is the time in which the crew is in the field, is the time in which you can move a drill. So it's decision time, okay? It's decision time. It's the minimum decision time. When I've asked them, I want automated AI-driven, from the moment you put something in the ground to the moment that you got a 3D model, I want 48 hours. They lost their mind, okay? They were not happy. All my geologists, all my geophysicists, everyone, okay? I always do this parallelism with a movie that a documentary, if you have not watched it, is the story of Netflix. So Daniel, that is the founder of Netflix, wanted, it's a very nice documentary, you should watch it. He wanted you to select a song, and the song would come straight away, okay? So he annoyed the hell out of his CTO for 3 years because there was a 2 seconds delay. And he's like, no, Spotify will never become a platform if you have to wait 2 seconds. In the documentary, you actually see that he and his CTO were fighting about this because the CTO was telling him, we need to change the internet protocol. We can't do this in less than 2 seconds. Long story short, not a lot of people know that Spotify sits on a change internet protocol. So this poor guy after 3 years had to change because Daniel was obsessed about this concept of your experience to be that you push from a random song like Twinkle, Twinkle, Little Star and gets to you in a picosecond. Okay, this was his vision. So when I started telling everyone, I want to go to 5 minutes, but I give you 48 hours, then you realize all sort of things that was happening. For example, people will get the sensors, put it on an SD card, then putting inside, then put it in an Excel, then upload it in the cloud, download it from the cloud, spend time looking. It was insane. Using 200 different tools, so it's fixable. So the first time that now we are, I think, at 32 hours, and we are trending down, adding stuff. So there is some madness. So at the beginning, no one understood what we were trying to do. Till we started working in Canada, that I think it was a perfect area, because in Canada, you can just discover for 4 months in a year, the rest is cold, okay? So they got a short period of time in which they can drill, they can explore, they can discover, so pressure was on. So we started working with them in the Athabasca region. It's far, and it's cold, and it's full of snow. And they were like, okay, 48 hours, 48 hours. The first time we gave a week, and the people were calling us 48 hours. So the fascinating thing is that for us, Athabasca was so successful in terms of interception, in terms of discovery, that that big contract that we got with Madden now to explore the entire Saudi, this is a 4 years, like multiphysics, AI on the entire platform, come from the Canadian people that were so successful, they got promoted into Saudi, and the Saudi, they were like, the Saudi, one of the Saudi pillars is to find a tier 1 deposit in the next, by 2030. And they've been trying to do this for 15 years, okay? So speed was the only way now. Speed is the only way now. So sadly, speed is the only way. So talking about iPhone and talking about fast things, like when you try to do something different, people really hate it. They really hate it. And they hate it for a long time. But then you realize, and you don't get it always wrong, you're going to go right, but then you realize it's kind of world-changing.
Excellent. So I would like one more question before we take this, because some of the answer already covering. So one more. I have 10 minutes. Excellent. So one more round of questions, then we go into the... Now we have the technology. We have the vision, very clearly described. So if it's one thing everyone here can do, leaving out of this room or in the next few days, what would that be to get in the right path with you guys?
For me, I think it's been said a couple of times already. Flavia said before that it took an entrepreneur from a different industry to impact this industry. I remember Mark Cutifani coming in on his first day in Anglo-American and saying, unless we get really, really good at this, we will be taken over by Toyota. And this industry is at real risk of being taken over and being run by people upstream. So what we need collaboration. We do not want to be, Fleet does not want to be seen as a service provider. Fleet wants to be seen as a business partner. And many of you will have heard of BHP's initiative with Explore. One of the rationales of the founding of Explore is that even a company such with such size and scale as BHP, we do not have all the answers. We have to be more collaborative. We have to have a good dose of humility in saying, hey, putting up our hands, let's go and look at what other people are doing elsewhere. Let's look at the really fabulous stuff that's happening out there, and let's pull it into our industry before it's pushed in by somebody else and we're pushed out.
Yeah, but what will be the small action, like Jeff said, just talk to us to collaborate, be part of Mineral X. How do people want to be part of your iPhone, whatever?
I actually, that's what I would like to see. And I haven't discussed this with Jeff and David a lot, but remember the 4 things that I told you that changed oil and gas and data sharing? This is a data problem, okay? So let's talk about data. They are not there, okay? And BHP is trying to lead the OSDO initiative that is literally taking what oil and gas has done for open AI and open source. Is struggling for a series of things, like these people in this room are people that love AI. We love AI. We love innovation. We want to see this industry to be successful. If OSDO cannot do this, let's do it as part of Mineral X. Let's build a collaboration team to find a way to bring APIs aligned. Yeah, we got people from Vale, from Rio Tinto, from Glencore. We got all the service provider. Andres and I, we've been trying, to find a time to talk for a couple of weeks. Do you know how much data Excalibur has? Do you know how much data we have? Kurt knows what we're talking about. It needs data. We need data. We are the people. Is there a way that we can lead this initiative? Can we be the Equinor or the OSDU? Or can we do this? So I think we can. I don't know if it's a Stanford initiative or if the guys want to help us, but that would be, if it's not this room, ain't gonna happen. Okay? Ain't gonna happen. We can wait 50 years and I'll be dead by then. Okay? So please, in the next 6-7 months, let's spend some time together. If you care about this problem, if you care about funding a way so that all the vendors around the world, they don't give you 1 million formats that are shit, okay? Work with me and work with a team, and we try to find a way to advance this industry. Sorry, I had to say a S word because it's a promise that I made to my marketing team. Every time that I present, I have to say a bad word. Okay.
You should hear Flavia's company All Hands have a much higher quotient of swearing.
I say the people who swear are very intelligent.
Yeah, I think from a point of comparison for me in this question that's been really interesting to see is that the Earth observation community has seemingly built like a quite successful standard in spatiotemporal access catalog sort of purely out of open source development processes, as far as I can tell. It's like really tech driven. It's basically builders just wanting to build a tool that they can use to then, collect data and operate on it. It's very, lightweight comparatively. It's basically just like a JSON specification that lets you do a bunch of things, and people have built great tooling out of it that's all open source. And I think, as Flavia was saying, this is the right community to do something like that, where we are interested in technology, we are builders, we want to do things, and not get caught in committees for 10 years trying to define stuff. And that's how we're potentially going to allow this to happen.
One last ask around data is that, I mentioned geologists are data pigs, and we can always get more data put into the public domain, etc. I'd like these brain boxes sitting over here over the next 6 months to be thinking about what happens in data poor environments. How do we get better at interpolation and extrapolation of existing data sets? Because even the largest companies in the world will go broke collecting data. So how do we get really, really good at finding insights in data poor environments?
Excellent. We got excitement here. Raise your hands. How many are here willing to collaborate? Not just with Fleet, but all together.
Let's go.
So we have 6 minutes. You answer most of the questions, but there is one here. Can you say something more about the technical challenges in your Madden project? In your MAD project or Madden project?
In my old MAD projects. The Madden one. A lot of pressure in the kingdom. The kingdom also operates just with kingdom sovereign data. So we had to create a JV in the country. Our satellite data cannot get out of the country. Very complex. Okay, I know. That was good. But
If you didn't figure that out.
Yeah, exactly. For the people that are really far. Complicated, okay? On the other hand, massive terrain, really, really, really big. Saudi Aramco has just opened a mining division. So they are going after lithium, while Madden is more copper gold oriented. They have been quite lucky with aluminium so far, but copper gold is what they're looking for. Really what the kingdom has told them, they want a tier 1 deposit with great grade. Not everyone wants that. Everyone wants that. Okay, so without satellite data, it will take us 20 years to map the entire platform. It's just massive. So on the other hand, it's a beautiful project. Like we have been running it just for 3 months already, working also with many parts in Madden. It's beautiful. Like beautiful places, beautiful subsurface. It's amazing. Chile is also something that I really like. I really like working in Chile. It's very cool as well.
And incredible support as well within the kingdom. I mean, unbelievably driven ambition, and when you get that level of support at across the entire business, that gives you a great tailwind.
I think we can do one more question. Historically, juniors were more efficient in prioritizing exploration, and majors preferred to acquire de-risk assets versus exploration spending. Do you work with juniors?
We did work with junior, and we actually then created a fund that invests in juniors. So the difficulty with juniors is how to explain this. Like, they die every second minute. That makes life. It's true. Like, it's like tech startups. We die every second minute too. But I think that important to junior cannot be underestimated. So we decided to invest, give them the technology in exchange of shares, because most of the time they don't have the money to pay for it. So we really, really, really try to support them all and try to elevate the industry a little bit, because this is where it starts. I actually found fascinating that the tier one now are going back a little bit on exploration and trying to unlock. I don't know what you think. We love.
Well, first of all, I want to blow apart the myth that juniors are more successful explorers. I mean, if you look at all of the majors, Anglo, BHP, Vale, Rio Tinto, at their resource books, they've built it enormously over the last 15 years, incredible success in brownfields environments, because that's a low-risk environment for them in which to operate. So the resource base has been built tremendously, and also they're not motivated to announce discoveries. It's not material to their bottom line. That aside, juniors do struggle financially to inject the kind of capital that it needs to transform the industry.
Excellent. I think we finished. Time is up. Thank you very much, Flavia.
Thank you, Doris.